Morning. I'm going to try to do the Chapter 11 review this morning. I've already tried to record this video once this weekend and had a glitch, so get to do it again. Not that that makes a difference to you, but it does to me. So my hopes would be that before watching the Chapter 11 video, that you just try to do all the problems, and that you're kind of, as you're watching the video, you're kind of focusing on the problems that you didn't get correct. And you should do all of my reviews probably before watching the videos. Kind of treat the review as a practice test. If you can do every problem on any of my reviews, you should be able to do every problem on my test. There's never intentionally anything tricky on my test. So if you haven't done the review yet, it wouldn't be a bad time to pause it, then do the review, and then come back and watch the review. So there's some comments on this first sheet that are relevant to this whole Chapter 11. And the first comment has to do with negatives. And in the TVM solver, the negative that we're going to be using to enter negative dollar amounts is the negative in the bottom row of the calculator, as opposed to the negative above the plus sign below the times sign. So in the TVM solver, every single negative that we're going to enter is that negative with the parentheses in the bottom row of the calculator. And then the TVM solver, which is on my calculator buried under the apps key, and then enter on the finance, and then enter on the TVM solver. So there's three different dollar amounts on this TVM solver. The PV stands for present value. It would be the amount of a car loan or a house loan if you're trying to figure out a house or a car payment, or the amount that you owe when you start making a bigger payment for a house or a car loan. So the PV in loan problems is generally a positive amount, and it's usually the amount of money that you owe or are borrowing. In savings problems, the PV would be the amount of money that you had saved up while you're adding to your savings, or the amount of money that you have saved up when you're withdrawing from your savings. Generally, if I'm only having to enter $1 amount, if I'm only entering just the PV, then the sign that I put for the PV won't matter with the number. Similarly, if I only had to enter something for the PMT stands for payment. That will be the amount of your house payment, the amount of your car payment, the amount that you're depositing from every paycheck into your retirement account, the amount that you're withdrawing while you're retired to pay yourself. If I only had to enter $1 amount and the PMT was that dollar amount, then it wouldn't matter so much, the signs. And the last dollar amount is FV, which stands for the future value. And I don't think there was an instance that we actually had to enter a future value. We might have had to compute the future value, so we never had to enter a value, so we won't have to worry about the sign. So ultimately, the only signs that we're going to have to worry about are for the dollar amounts for the PV and the payment. If you're only entering one of those two amounts, then the sign doesn't matter. It's only going to be the case when you're entering both PV amounts and PMT amounts that the signs are going to make a difference. And I tried to say what signs you need to have. So if I'm only entering $1 amount, sign doesn't matter. But if I have to simultaneously enter amount for both a PV and a PMT, then the signs are going to be a big deal. And that's what this line was trying to say, that if you're only entering $1 amount, sign doesn't make any difference. Generally, I'm never going to enter amount for the future value. I'm always going to enter 0 for the future value. Sometimes in savings problems, I'll be solving for the future value, but I'm not entering amount, so I don't have to worry about entering amount there. So this little bulleted item on this sheet talks about entering values for both the PV and the PMT. So, and I tried to break it down to loans and savings problems. Generally, in every loan problem, if I'm entering both a value for PV and PMT, then the PV should be positive, the payment should be negative, and the only time in loan problems that I'm entering both values for PV and PMT is the kinds of problems where I'm trying to figure out how long it's going to take to pay off if I change my payment. So in loan problems, this is the only time I enter values for both the PV and the PMT is when I'm answering the how long to pay off a loan question, and in that instance the PV should be positive, the payment should be negative. In savings problems, there were two instances when I would enter both values for the PV and the PMT. And when we did the savings problems, we kind of broke the problems into two big types. One type of problem had to do with when I'm building up my savings for retirement, and the second kind of problem would be when after I'm retired, when I'm starting to withdraw from my savings. And in both of those instances, it might have been the case that we had to enter values for both the PV and the PMT. In a savings problem, while I'm saving, then both the PV and the PMT need to have the same sign. And it doesn't really matter if you make them both positive or both negative, but it's customary to make them both negative. But while you're saving in savings problems, if you enter a value for the PV and the PMT and you have the same sign, then it's not really going to matter which gets which sign. Similarly, in savings problems, once I've done all my saving, I'm retired, I'm pulling money out for retirement, the signs on the PV and the PMT will make a difference if I have to enter values for both figures. And generally, it would be fine if you make the PV positive and the PMT say negative. Actually, as I look at this, I probably would actually make the PV negative and the PMT positive. So let me change that, and I'll go back to my office at some point and type that over. But the truth is, as long as when you're withdrawing money in a savings type situation, if you had to enter values for both the PV and the PMT, if you just made them have opposite signs, it really doesn't matter which one is positive and which one is negative. So that's a big deal. Getting your signs right when you're entering values for both the PV and the PMT. Every scenario that we'll deal with in this review or on the test is looked at in those three little instances. Some other things in the saving problems, the words every 2 weeks and twice a month are different. Every 2 weeks is 26 times per year, whereas twice a month is 24 times per year. And the PY and the CY in savings problems, when I see the word every 2 weeks, it's going to be 26. When I see twice a month, I'll be 24. In savings problems, if I see that I'm making monthly deposits or monthly withdrawals, the PY is 12. That's not such a tricky one. And if I'm doing annual deposits or annual withdrawals in savings problems, the PY is 1. Those aren't that tricky. But in the savings problems, I even have to think about it when I see the words every 2 weeks and twice a month to make sure I get the right PY. And then in loan problems, we didn't do anything but have monthly payments. So in all loan problems, we'll have the PY and the CY 12. So these are some of the important items in Chapter 11, and real specifically, this bottom half of this sheet. This is where, if you're going to mess up on the test, this is where you're likely going to mess up, because some of this is kind of straightforward, but signs on the PV and the PMT, as well as getting the correct PY and CY, you can definitely go wrong there. All right, so now, with that being said, I'm going to dig into the review, and like to think that you'd have all the little subtleties in this section memorized. The first problem on the review talks about Joe wanting to qualify, see how much money that he can make for a mortgage payment. Of course, that's the PITI, principal, interest, taxes, and insurance, that Joe was trying to figure out what he can qualify for. And to do this, to figure out what your monthly payment that you can qualify for, the first thing we need is the monthly income. And that's going to be computed by taking Joe's annual income and dividing it by 12. Don't need a TVM solver for any bit of this problem 1. So I hit second and quit out to get out of the TVM solver screen. Now I'm just dividing 40,000 divided by 12. And this gives that Joe makes $3,333.33 per month. Now what I need to do is take that $3,333.33, multiply it by 28%, and just leave that number fixed, and then multiply it by 36% and deduct Joe's other bills, which would be like car payments, credit card payments, student loan payments, child support payments, any kind of monthly payment that technically need to have, like cable, they wouldn't deduct that, cell phones, it wouldn't deduct that, food, it wouldn't deduct that, but by bills in this case, I mean his car loan and his credit card payment. So let me do both the computations. So I'll take this $3,333.33, multiply it by 28%. I'm rounding to the nearest dollar. This says if Joe didn't have any debt, that the bank would let him have a maximum mortgage payment of $933. I'm going to do this computation, and the answer to the question is going to be the smaller of these two amounts. So I'm going to do my first computation, which is 28% of his monthly income, and now I'm going to do 36% of the monthly income less bills. So I'm going to take the $3,333.33, multiply it by 0.36, which gives me $1,199, and it's actually going to be $1,200. I see 99 cents. If I wrote $1,199.99 temporarily here, I'd live with it. I don't mind if you're off by a penny because you round differently than me. But what I'm going to do is this 8 that's in the third decimal place would round the penny, 9 pennies up to 10 cents, which is around the 90 cents up to $1, which is going to round the $99 up to $200. So I'm going to say this multiplication gives me $1,200, and I'm going to subtract bills of $250 and $200. I'm going to add those together and get $450. So now I'm going to subtract the 36% figure, which I'm rounding to $1,200, less Joe's credit card payment and loan, auto loan payment, and I get $750. The answer as to what mortgage payment Joe is allowed to qualify for is the smaller of these two amounts. So you need to do both computations and take the smaller amount. This is why in my answer to this problem, I said Joe can qualify for a $750 per month mortgage payment because I did the two computations, took the smaller of the two amounts. I don't need the TVM solver at all to compute how much of a monthly payment, principal, interest, taxes, and insurance somebody can qualify for. 2 is essentially a duplicate of 1. It just gives another practice to figure out what mortgage payment that, in this case, a couple can qualify for. So I pooled their income together. They made $100,000. Maybe Jen made 70 and George made 30. It doesn't matter when I pool their income who makes what. I'm just giving a total income here, and I'm going to do essentially the same computations. I need to find their monthly income, and I gave an annual income, and so I'm going to get the monthly income by taking the annual income and dividing it by 12. So I just take the $100,000 that they make between them, divide it by 12, and I get a monthly income, and again, this thing that needs to be rounded, of $8,333.33. Just like I did with Joe, I'm going to take the 28% of the monthly income and the 36% made as a decimal of the monthly income less bills, and the amount that they can qualify for as a monthly payment would be the smaller of the amounts. So I'll do the first computation, do 0.28, which is 28% as a decimal, times $8,333.33, and I get $2,333.33 as one of the amounts I need to, of one of the two amounts I have to compare. I'll do the two computations, take the smaller amount. The second computation is taking 0.36, multiplying it by the $8,333.33, and I'm going to round that to $3,000, just like I rounded in the last instance. The 8 in the third decimal place rounds all these nines up, and it's going to bump me all the way up to $3,000. So I'm going to take the $3,000, which was 36% of their monthly income, and less bills, and their bills are the $650 a month for their 2 car payments, and their $200 per month for the credit card payment. So that's $850. So I'm taking the $3,000, which is the 36% of their income, subtracting the $850. That comes out to $2,150. And once I do the two different computations, the 28% without any subtraction, the 36% subtracting bills, I take the smaller of the two amounts, and this is why in my answer I said that Jen and George can qualify for a $2,150 per month payment. It's the smaller of the two computations. So neither problem 1 nor problem 2 needed the TVM solver. Problem 1 and 2 essentially were the same problems. They're just slightly different variations of the same style of problem. Problem 3 just wants me to compute a loan payment and doesn't talk about property taxes or homeowners insurance. Just says compute a payment for a $175,000 30-year loan. I'm assuming that there's monthly payments. My N, so I'm going to need the TVM solver for this. And in my TVM solver, you need an N, an I, a PV, a PMT, a future value, a PY, a CY, and for every problem we left the end choice on the bottom, so that's not an issue. And I'll just go through it and decide what my values are going to be, and then I'll go to my calculator to figure these out. First thing is the N. If I put 30 in for N, my calculator is going to think that's 30 months or 2.5 years. Because it's 30 years and I'm making monthly payments, the N's going to have to turn out to be 360, which I can get just by typing 30 times 12 in for the N in the TVM solver. The interest rate in this instance goes in with its decimal as 4.85. If you made it 0.0485, your calculator would think that it's less than 1%. The PV is the loan amount. I only see $1 figure, so it doesn't really matter because I'm only going to enter $1 figure, the sign that I attach to the dollar amount. And usually we make the loan amount for a car or a house a positive value. I'm solving for the payment, so ultimately I'm going to arrow up to the PMT and hit alpha solve. And at the end of paying off the loan, I want the future value to be 0. The PY is the 12 payments I'm making per year. And in all loan problems, the PY and the CY, how often you're paying interest and how often you're making payments, coincide. So I'm going to get this answer, hopefully, of $923.46 by going to my TVM solver. On the N portion, I'm typing 30 times 12. The I am typing 4.85. The PV I'm typing 175,000. The PMT, it says 7,000. It really doesn't matter what value is in your PMT. You don't have to retype that. Whatever's in there can stay in there. Your calculator will just type over it. I have the FVOK at 0, the PY and the CY at 12. The PMT at the bottom says end. Once I have all the values in except for the correct payment, I get my cursor flashing at the PMT. I hit the green alpha button and I hit enter. And I see $923.46, which is the answer to problem 3. So on a test, if you wrote 923.46 in your answer blank, you'd get the correct answer. If you wrote something different than 923.46 on your answer blank, then I'd look to see how much detail you gave me in terms of what you typed in on your calculator. It's not uncommon for somebody to have all this correct and then write the wrong answer, which means they just entered one of these numbers wrong on their calculator. They knew what to enter, but they somehow just entered something wrong. And if that's the case, you would like lose a -1. But if I see that, oh, you have the PV wrong or the I wrong, then I'll take more points off. So if I can tell where you made your mistake, then you'll get some partial credit. If you didn't show any of this and you showed an answer that was wrong, then if it was a 7-point problem, you'd lose 7 points. The only way I can give you partial credit for a wrong answer is if you gave me the detail of what you typed in on your calculator. And that's the end of that problem. 4 looks pretty involved. I'll probably need another sheet of paper to finish up number 4. So it talks about Laura making $64,000 per year. She doesn't have a car payment, but she has credit card payments and student loan payments of $450 per month. This portion of the question that refers to Laura, this is the bit of information in the problem that will help me answer the first question. Up until there, that helps me compute how much Laura can qualify in terms of a monthly payment. Apparently it's $1,470 per month. To do this is just like problems 1 and 2. So part A of number 4, I need to figure out how much Laura can qualify for as a monthly payment, PITI, and I actually added the taxes and insurance I'll deal with later. So I'm going to get Laura's monthly income to figure out how much she can qualify for. I'd hit second and quit, get out to the main screen. Get her monthly income, which is $64,000 divided by 12, again with the 33 cents. I get $5,333.33 as Laura's monthly income. Now I'm going to compute 28% and 36% less fees. Take the smaller of the two amounts. So I do 28% and I can actually write this, 36% less bills, take the smaller of the two amounts. So $5,333.33 times 0.28 gives me $1,493.33. And then I'm going to do the next computation, the $5,333.33 times 0.36, which gives me something again that needs to be rounded up. That's $19.9988. It's going to round up to $1,920. And then I need to subtract the $450 that she has in monthly bills that are, not utilities and necessities. When I do that, I get $1,470. And I take the smaller of the two values. In this case, the $1,470. So the reason my answer for 4A is $1,470 is because I did the computations, 28% of her income, 36% of her income less bills, took the smaller of the two amounts. So the answer to 4A is $1,470, and I think that's going to make it so I don't have to look at the first sentence in this question anymore. Second thing I want to do is compute the payment if she took a 3.5% loan, and I said to include taxes and insurance. And let me do, first of all, I'm going to do the PI portion of the payment on my TVM solver, and then I'm going to add the taxes and insurance part of the payment, the TI. So the PI portion you get by using the TVM solver. You do the N for the number of payments, the I for the interest rate, the PV for the amount that she's borrowing, the PMT I'm going to solve for, the future value is what I want to owe when she's done paying the loan, which is 0. Both the PY and the CY are going to be 12 for all our loan payments. And I'm going to have my calculator on N for all loan payments. So to do the principal and interest portion of Laura's payment, if she takes a 15-year loan at a 3.5% interest rate, The N isn't going to be 15. 15 would look like 15 months. The N's actually going to be 180, which I get by taking 15 years times 12 payments per year. The 3.5% is going to go in as the interest rate, and then the PV is the loan amount, and that's going to be the difference between the $180,000 that the house is selling for and her down payment of $12,500. If I do that subtraction, in for the PV, I'm going to put $167,500, which is the amount of money that she's borrowing. Even though the house cost $180,000, she's only borrowing $167,500. The payment's what I'm going to solve for. And that's going to give me the PI portion of the payment, which is not going to be the $1,407. That's the final answer. So when I go to my apps, enter, I type in 15 times 12, in for the N, I type in 3.5 in for the I, 167,500 for the PV. Everything else other than the PMT is right. I hit alpha and enter, and I get $1,197, and I'm going to round that to 43 cents. You notice that's not the answer that I have written here. So I have $1,197.43 as the PI, principal and interest portion of her payment. I need to add the taxes, and I need to add the insurance. To get the taxes, her taxes are $1,800 per year. I need to take $1,800, which is the yearly tax amount, and divide it by 12 to get the monthly tax amount. I don't do that from the TVM solver. I second and quit out, clear the screen up to clean it up, and go 1,800 divided by 12. That's going to give me $150 per month that needs to be put away for taxes. And similarly, for her insurance, I'm going to take $720, which is the annual insurance, and divide it by 12 to get the monthly insurance, which is $60. If I add those three amounts, the principal and interest portion of her payment, plus the taxes and the insurance, that's Laura's total payment, which can't exceed $1,470. Turns out not to here. So if I take the $1,197.43, add the $150, and add the $60, I get this $1,407.43, which would be her total PITI payment on a 15-year loan. Maybe $1,400 is more than Laura wants to take and pay each month. So next I want to do the payment under a different scenario. It's not uncommon that when you're looking to borrow, you compare 15 years and 30-year financing. It's nice to pay a loan off after 15 years because you pay a lot less interest, but the payment's a lot higher. So now I'm going to compute a 30-year payment, and I need to compute the PITI payment. Whether she takes a 15-year loan or a 30-year loan, that doesn't change the amount that needs to be put away each month for taxes nor insurance. The property tax bill is $1,800 per year. It's going to be $150 per month, regardless if she financed for 15 or 30 year. Similarly, the insurance of $720 doesn't go up or get cheaper if you take a 15-year loan as opposed to a 30-year loan. The next thing I'm going to do is finish up Part C by computing the principal and interest part of her payment. And to do that, I'm going to use the TVM solver. The N is not going to be 30. That would be 30 months or 2.5 years. The N is going to be 360, which is 30 times 12. When you finance for 30 years, you pay a higher interest rate than 15 years. I'm going to type in 4.5 for the I. The PV is still the same, 167.5. She's not borrowing more or less if she's financing for a longer period of time. I'm still solving for the payment here. The future value is still going to be the zero that she owes when she wants to owe when she gets done paying. The PY and the CY for all loan problems are going to be 12, and the bottom of my calculator is going to be an end. When I do that computation, I'll get the PI portion, the principal and interest portion of her payment. So I go apps, finance, enter. For N, I'm typing 30 times 12. I can see the 360, 4.5 for the interest rate, 167.5 for the present value, 0, 12, and 12 an end. And now I solve for payment by hitting alpha and enter, and I get $848, and I'm going to round that to 70 cents. 0.697, the 7 rounds the 9 up to a 10, which rounds the 6 up to a 7. So I'm going to write $848.70 for the principal and interest portion of her payment. To get her total monthly payment, the amount that she'd send to the bank each month, I have to add the principal, interest, taxes, and insurance together. If I add these figures together, getting off the TVM solver screen, and take the $848.70, the PI portion of her payment, plus the $150 taxes, plus the $60 insurance, I get $1,058.70, and that's going to be the answer to part C. So Laura, comparing her options, if she could handle the $1,400 payment and was comfortable making that, then paying that extra $360 a month is going to have the house get paid off over the loan paid off over 15 years rather than 30 years. But it doesn't mean she has to take the higher payment. Maybe she just doesn't feel comfortable making that payment. So that's all for force A, B, and C. Each of the answers is already written on the sheet, so you're just trying to target those answers through your computations. So question 5 is a duplicate of question 4 using Betsy as opposed to Laura. Question 6 kind of tags along with 5C. It talks about Betsy and her taking the loan in part C and then seeing what happens, if she changes her payment in the future. And so 5 and 6 tie together perfectly. So to do 5, the first thing I'm going to do is find out how much Betsy can qualify for in terms of a monthly payment. And to do this, I need to find her monthly income. And that first sentence is going to help me do this. Virtually guaranteed that when you're given a test question, that it's just going to be a duplicate of one of the test questions on the review with numbers changed. I don't even think I changed the people's names. So to do how much she can qualify for each month, I get her monthly income, which I'm going to say is $4,166, and I'm going to round to 67 cents. Fourth time we're doing this, so hopefully this is getting to be routine. I need to find 28% of her income and 36% of her income less bills and take the smaller of the two amounts. So first I'll do 28% of her monthly income, so I'm going to go 4166.67 times 0.28. And I get $1,166. I'm going to round that to 67 cents. Now I'm also going to do 4166.67, which is our monthly income, times 36%, and that gives me $1,500. But that $1,500 I need to less bills, and her bills are $400 per month that need to be deducted. 1,500 minus 400 is 1,100. And when I do my computation to figure out how much she can qualify in terms of a monthly payment, I do the 28% without deducting bills, the 36% deducting bills, and I take the smaller of the two amounts. The smaller of the two amounts is $1,100, and that's why the answer to 5A should be $1,100. So the computations for computing how much you can make as a monthly payment are just that's constant. Get the monthly income, compare 28% of the monthly income to 36% of the monthly income less bills, you take the smaller of the amounts. Part B says, what if Betsy takes a 15-year loan? What would her payment be? The TVM solver does the principal and interest portion of her payment, and let me compute that now. So to do the principal and interest portion of Betsy's payment, I need to use my TVM solver, I need a value for N, a value for I, a value for PV, a value for PMT, a value for future value, and for all loan problems, the PY and the CY are going to be 12, and I'm leaving the calculator on end, so those are kind of non-issues. In part B, Betsy's thinking about figuring out what her payment would be under a 15-year loan, and I'll just take the 15 years, multiply it by 12, and enter that amount, which is going to be 180 in N. The interest rate for part B is 3.5%. The PV is the loan amount, and it says she's purchasing a house that costs $140,000, putting a $5,000 down payment, so her PV, the loan amount, is going to be $135,000, which is the difference between the $140,000 and the $5,000. I'm going to solve on my calculator for the PMT, and in home loans and car loans, the future value, we generally always put 0. It's the amount we want to owe when we're done paying it off. So I'm going to go to the TVM solver and enter those amounts. Apps, finance, enter 15 times 12, and then 3.5 and 135,000. Everything else is right but the payment. I hit my green alpha button and hit enter. I get $965.09 for her PI portion of her payment. Actually says 965.09. Not that that looks like a 5, but that's a 5 there. Now I'm going to do her taxes. Her taxes are supposed to be $1,800 per year. So I'm going to take the $1,800, which is her yearly taxes, and divide it by 12 to get the monthly amount for her taxes. I don't need to be in the TVM solver for that, so I second and quit, get back to my main screen. $1,800 divided by 12 gets $150 per month for her taxes. I also need to find out her monthly insurance. I do that by taking $840 and dividing it by 12. When I take $840 and divide by 12, I get $70. So I'm going to add these three values, the principal and interest portion from the TVM solver, the $965.09, plus the property taxes, plus the insurance, and that would be the rent check she'd have to pay every month. So $965.09 plus $150 plus $70, and I get $1185.09 for the answer to part B. So that's more of a loan payment than Betsy can take. So even doing that computation would make her understand that the bank wouldn't let her do that. That they would think that would be excessive. She wouldn't be able to afford that payment, so they wouldn't even let her do that. So this is a non-consideration for Betsy. And the last problem, Laura could have qualified for either, and then it'd be up to her to decide whether she could handle the higher payment or she'd rather not make the higher payment. For part C, I'm doing the monthly payment if Betsy took a longer loan, and my TVM solver is going to get the principal and interest portion of her 30-year payment, which is the one that she can qualify for. The taxes in the 30-year payment and the house insurance in the 30-year payment are going to be the same, because taxes and insurance don't hinge on the amount of money that how long you take your loan for. So I'm going to find out her total monthly payment. Need to go to the TVM solver to do this, to finish up and get the PI portion. For part C, she's taking a 30-year loan. The N's going to be 30 times 12. The I is going to be the 4.5% for this loan. The PV is the same $135,000, which is the $140,000 loan, lesser down payment. I'm solving for the PMT. The future value is going to be 12. And in all loan problems, car and house, the PY and the CY are 12. When I enter those, I'm going to get the value for the PI portion of her payment. So I'll go finance, enter, 30 times 12 for the N, 4.5 for the I. Currently, it's like 3.875 for a 30-year loan. So I probably wrote these problems last semester, and interest rates have come down quite a bit. My PV is still okay. My FV, my PY, and my CY are still okay. I'm going to cursor, so that's my cursor's flashing on the payment, hit my green alpha and enter, and I get 684, and I'm going to round that to 0.03. So the principal and interest portion of her payment is $684.03. And now I'm going to add the principal, interest, taxes, and insurance on my main screen by hitting second and quit. Do 684.03 plus 150 plus 70, and I get 904.03. And that loan Betsy can qualify for. The answer to part C is $904.03. Question 6 assumes that Betsy couldn't take this loan, and she actually took the loan in part C, and asks some questions about that particular loan. And conveniently, I just did problem 5C. That's going to make problem 6A real quick to do, and then 6B not so quick to do. But when I get into problem 6, this amount, this $684.03, the principal and interest portion of her payment is going to be an important factor in the computations. These parts, they're going to be not considered as much when I'm doing the computations on my calculator, because on my calculator, the TVM solver and the finance package on my calculator, it only concerns itself with the principal and interest part of a payment. It doesn't do the taxes and insurance. I have to do those outside the TVM solver universe. So problem 6A says, let's say Betsy took that loan in 5C that we just computed. She took the 30-year loan. Her payments were the $904.03. Of it, $684 was principal and interest. So let's say she made that $904 payment for 5 years. What's her balance going to be? To do a balance, I need to use the BAL feature. And I have to do BAL, the number of payments made, and it's going to be BAL 60 or BAL 5 times 12, because she made 5 years of payments, 12 payments per year. To figure out the answer to 6A, I'm assuming I just did 5C. I'm going to hit my apps button, I'm going to enter on finance, and instead of going into the TVM solver, I'm going to run down and find the BAL, which on my calculator is hidden on number 9. I go BAL, and I go 5 times 12 and do a parentheses. Or I could have went apps, finance, BAL, and typed in 60. Get exactly the same amount, because 5 times 12 is 60. If I did BAL 5, that would count computer balance after 5 months as opposed to 5 years. So I needed to convert the 5 years that she made her payments into months. And 5 years is 60 months. And her balance is going to be the answer to this question. After 5 years, her initial balance was $135,000. It's now down to $123,000. So after 5 years of making payments of $1,000-ish a month, her payments were $904 a month. Her balance went down $12,000. It's not uncommon that after you've been in a loan for a while, you're making more money, and instead of refinancing, you start making bigger payments. And that's what part B says. Let's assume Betsy's making bigger payments. What's going to happen to her? How much longer it's going to take? So in general, in this scenario for problem 6, Betsy would have 25 years left to pay on her loan. She took the 30-year loan. She paid on it for 5 years. So she has 25 years left. And she's making more money. She wants to get the loan paid off quicker. And how does that impact my making a bigger payment? How does that impact how quickly the loan's going to get paid off? And 6B wants me to answer the question, what happens when Betsy makes a bigger payment? Well, if somebody makes a bigger payment, and I want to know how much quicker the loan's going to get paid off for. I'm solving for N. The I for this loan is still the same, 4.5%. To answer the question of how much longer it's going to take to pay off a loan making a bigger payment, when you go to the TVM solver, the PV needs to be the amount that you owe when you're making the bigger payment. I forced you to compute that when we did part A. And it probably should be positive. The PMT is going to be the new payment that Betsy's making, and it should be a negative. When I'm entering values for both the PV and the PMT, the signs make a difference. And when I'm using the TVM solver, I'm only using the PI portion of my payment. I'm not using the taxes and insurance. So Betsy, when she owes $123,000, she's going to add $200 to her principal and interest portion of her payment, and the PI portion of her payment is going to go up to $884.03. Her real payment's going to go from $904 to $1,104, but the taxes and insurance don't go in the TVM solver. So to figure out how much longer it's going to take to pay off with the new higher payment, I'm going to enter the same interest rate that the stated interest rate on the loan of 4.5%. I'm going to type in the amount that she owes when she's making the bigger payment, which is $123,000. I'm going to make that'll be positive. I'm going to type in the new principal and interest portion of her payment. The last 684.03 I got from looking at my answer to 5C, added the $200 that she's going to add to her payment to get the 884.03. These values need to have opposite signs. She still wants to owe 0 in the future. PY and CY, not that that looks like that, is supposed to be 12, and the back of the calculator's on end. When I do my computation, I'm going to get 197.22. When I divide that, and that's how many months, and I'm going to divide that by 12 to get years. On your test, I take either 197 months or 16.4 years. So let me go to my TVM solver, apps, finance. Doesn't matter what's in the end, it's going to be canceled out. The I is still 4.5. I type 123,063.19 for the PV, negative 884.03 for the PMT. Everything else is okay. I arrow up to the N, hit the green alpha button, and then enter, and I get 197.22. That would be an acceptable answer to say it's going to take Betsy 197 more months to pay off her house loan by adding $200 to her payment. If I quit out of the finance screen and took 197.22 months divided by 12 months per year, I'd get 16.4 years, which is like maybe 16 years, 5 months. So instead of having 25 years to pay her loan off because she paid 5 years on a 30-year loan, by bumping her payment up $200 per month, it's going to go down to 16 years, which is a big, it's a 10-year savings or 9-year savings. That's all for 6B. I think that's all for the home loans. The next thing we'll do is car loans. Car loans are a little bit easier. Oh, I guess not. I still have one more home loan to do. This is Bill. Bill is borrowing for a house, and we're just doing the part A is the principal and interest portion of his payments. That needs the TVM solver. Part B of this is not something that needs the TVM solver. Part C does. So let me do part A. Compute Bill's payment. I'm not doing anything about qualifying. There's no taxes or insurance here. I'm going to use the TVM solver to figure out Bill's monthly payment. Bill's N is going to be 30 times 12. It's 30 years times 12 payments per year. Bill's interest rate is 5%. The PV is the loan amount. I don't see anything about a down payment. $350,000 now is a really nice house. The payment is what I'm solving for here. The future value is going to be 0. For all savings problems, my PY and my CY are going to be 12. I'm going to leave my calculator on end. And apparently, I'm going to get $1,878.88 for his non-taxes and insurance, his principal and interest portion of his payment. So my N is 30 times 12. My I is 5%. PV 350,000. Everything else is good. Solve for the payment. I get $1,878, and I rounded up to 88 cents. So part A needed the TVM solver. Part B, I'll sneak down here. For part B, to figure out the total interest, you take the total of your payments less the loan amount. The difference between the amount that you pay and the amount that you borrowed is your total interest. His loan amount was $350,000. His total payments is going to be the $1,878.88 times the number of payments, and that's 360 payments. If you looked at your N when you did the 30 times 12, you got 360 payments. So I'm going to take the, back on the main screen, the $1,878.88 that he's going to pay each month for the principal and interest times the 360 months. That's going to give me $676,396.80 in total payments. The difference between the $676,396.80 and the $350,000 that Bill borrowed is the interest that he's paying on this loan, which is $326,396.80. And if I look at my answer there, that's how I did that. So you do not use the TVM solver to compute how much interest Bill is going to pay. So on a 30-year loan, you've got a much lower payment than on a 15-year loan, but on a 15-year loan, you paid less interest, and it's paid off after 15 years. In Part C says, this has really, it has nothing to do with Part B. Part C works more with Part A. I want to compute Bill's balance after 15 years. And to do a balance, I'm just going to go balance 15 times 12, or balance 180. To get a balance, I need the balance part of the TVM solver. So I go apps, finance, not actually TVM solver. I go down to BAL, and I could either type in 15 times 12 and hit enter, or I can go apps, finance, go down to balance, and if I knew 15 years meant 180 payments, I'd get $237,593.68, which is the answer to Part C. Now that's everything with home loans. The next part is car loans. Car loans are a little bit easier because you don't have the 28% and 36% figures to worry about for car loans, but you do have the rest of the issues. So Alyssa's going to borrow $12,000 for a car in question 8. She wants to make 60 payments, which is a five-year loan, compute her monthly payment. To compute a monthly payment, I don't have to worry about taxes and insurance. The N is the number of payments, which is 60. The I is her interest rate, 7.9%. Doesn't sound like a great interest rate, but I haven't priced car loans recently to know. The PV is about the loan amount, which is $12,000. The payment is what I'm going to solve for. I'm going to get that $242. The future value, she's going to owe 0. For all loan problems, the PY and the CY are 12. And for every problem that we're doing in this chapter, the back of the calculator is left on end. So I go to my TVM solver, apps, finance, enter, type in 60 for the N, 7.9 for the I. Clearly I did something bad there. 7.9 for the I, $12,000 for her loan amount. Everything else is okay. I hit alpha and enter, and I get $242.74 for her monthly payment. Part B says computer balance after 2 years. And to do that, I can do balance of 2 times 12, or I can do balance 24. 2 years is 24 months. So I just computed the payment. I second and quit out of the TVM screen, go apps, finance, go down to balance, hit enter, type in either balance 24 or apps, finance, balance 2 times 12. Turns out it doesn't matter if I close my parentheses or not. And I get the same $7,757.78. That's the answer to part B. C says after 2 years, she's going to bump her payment up. How much quicker is it going to take her loan to get paid off? Generally, she would have had 3 years left because 60 payments is a 5-year loan. She's made 2 years, so she owes 3 years. By bumping up her payment, it's going to take her down a whole year. It takes her down to 2 years and a month. So for part C, if I'm answering a question, how long is it going to take to pay off when I'm making a higher payment, I'm solving for N, which is the number of months. If I divide it by 12, I get the number of years. The PV is the balance that she has when she's making the larger payment, which is $7,757.78. When you're figuring out how long it's going to take to pay something off, the PV and the PMT need to have different signs. And for my PV, my PMT, I took her payment of $242.74 and I added $100 to it to get the $342.74. And when I'm answering the question how long it's going to take to pay off a loan, the PV and the PMT need to have opposite signs. My FV needed to be 0, my PY and my CY needed to be 12. And when I do this computation, I'm going to get 24.59 months. I'm doing it in the TVM solver screen. So apps, finance, enter. N doesn't matter. The PV needs to be the 7757.78 that she owes when she, after 2 years. I put it in the wrong spot, 7757.78. The PMT needs to be negative, and the amount of the new payment, which is $342.74. Everything else looks okay. I'm going to arrow up to the N, get it flashing, hit my alpha button, hit enter. That's how I got the 24.59 for the number of months. And if I wanted to change that to years, I would just go to my main screen and type 24.59 divided by 12. That's just a little over 2 years. So saying 24.59 months is a perfect answer. Saying just a little over 2 years would be perfect. It would be 2 years of full payments, and then the last payment, that 25th payment, is going to be a partial payment. It won't be a full payment. Nine, I think, is the last loan problem, and then we get into savings problems. The savings problems, I think, are a bit easier. So Beth is going to borrow $36,000 for 6 years, and she's getting a 4.9% interest rate on her new truck, and she wants to figure out what her monthly payment's going to be. Again, if you go to the dealer and if this was your position right here, your payment probably is going to be slightly higher than this $578.11. This is because my calculator assumes, like today is February 20th, that my first payment would be due March 20th. And in fact, it probably would be April 1st that my first payment would due, because there's 10 days between when my calculator thinks I'm going to make my payment and when my actual payment's going to be. There's a little extra interest that I would owe, and it's going to be amortized through my payment, and my payment will likely be subtly different than this, for what that's worth. So when I go through this on my TVM solver, my N needs to be the number of payments. It says she's financing for 6 years. 6 years is 72 payments. I'm going to type in 6 times 12, or 72 for my N. My I is going to be the interest rate that Beth is paying, which is 4.9%. The PV is going to be the loan amount, which is $36,000. The payment is what I'm solving for. It's going to be $578.11, but I don't know that until I do the computation. The future value is going to be the zero that I want to owe when I'm done paying off the truck. The PY and the CY are going to be 12. I'm going to leave my calculator on end. If you're doing a lease, to figure out your lease payment, the residual value for your lease goes into the future value, and it would have a negative sign, a different sign than the PV. Didn't want to get into leases, but they're not that hard. You can compute lease payments on your calculator. Just pretty easy. I just didn't want to layer the difficulty any more than I did. So I'm going to go apps, finance, into my TVM solver. My N is going to be 6 times 12. My interest rate is 4.9%. $36,000 is what she's borrowing. And everything else is good. I solve for the payment. Alpha, enter, and I get $578. I'm going to round that to 11 cents, which is the answer to part A. Part B is how much interest. The amount of interest is the total payments less the loan amount. The loan that Beth had for this truck was $36,000. Her total payments is going to be the $5,623. Whoops. It's going to be the $578.11 that she pays each month, and it's going to be times the 72 payments, which is the number of payments she's going to make over 6 years. That's 6 times 12. So her total payments, I get out of this TVM screen to do this computation, take 578.11, multiply it by 72. So she's going to make $41,623.92 in payments on the vehicle, but her loan is only $36,000. The difference between her total payments and the loan amount is the total interest that she pays. That's almost $6,000, $5.5 grand. So the total interest for Beth is $5,623.92. So that's the end of the loan problems. Most of the review is loan problems, and the rest of the review is savings problems. When we get into the savings problems, the big deal that you're going to have to worry about is the PY and CY. So getting back to this, if I see every 2 weeks somewheres in the wordings in the savings problems, my PY is going to be 26. If I see twice a month, my PY is going to be 24. And there's going to be 2 types of savings problems. Well, there's going to be probably problems where I'm going to have to enter both PV and the PMT. While I'm depositing, the PV and the PMT get the same signs. While I'm withdrawing, the PV and the PMT get opposite signs. So now I'm going to dig into these savings problems. The first savings problem is the nice savings problem because it's a savings problem that only has $1 amount. I don't have to worry about signs at all. So I'm depositing $300 a month into a retirement account. I'm getting 8% interest per year. And I was kind. I said, I'm depositing twice a month, and I said use 24 because twice a month is not the same as every 2 weeks. I'm not sure I'm going to be this kind on the test to tell you that this is 24. So to find out how much your money's going to grow to, the N needs to be the number of payments you're making. And in this case, I'm making deposits for 15 years, 24 payments per year to find the amount of money I'm going to have in 15 years. If I just did 15, that would be like 15 payments, which is like 7 months, 7.5 months. So I'm going to go 15 times 24 for the N. The I is a very aggressive 8%. I used to use 11% for savings, retirement savings computations until the market hasn't been so nice recently. So I've backed off. But 8% is over 15 years. You'd like to think you could get that. You definitely have some years you do better, some years you do lower. But averaging that isn't unheard of. To finish up, to get this $208,000 answer, the PV is any money that I have already saved up while I'm depositing, and I don't see that I have any money saved up, so I'm going to make that 0. The PMT, it's probably nice if I made it negative, but honestly, you don't need a sign there. I'm solving for how much money I'm going to have in the future. The PY and the CY are the 24 payments that we're making each year. And I'm leaving my calculator on end. So if I get into my TVM solver and in for N, type 15 times 24. In for the I, type 8. Zero out the PV. Type in negative 300 for the PMT. 24 for the PY and CY. Go up to the future value, hit my green alpha button and hit enter. I get the answer of $208,214.82. B, same scenario. It just changes one thing. It changes the N. I'm going to do exactly the same computation to figure out the balance for 30 years as compared to the balance for 15 years, other than I'm going to change the N because everything else about the savings problem is going to be the same. The interest rate's going to be the same. I'm still making deposits twice a month, still making a $300 deposit. Entering these amounts will give me the almost $900,000 that you have over 30 years. So between 15 and 30 years, you don't double your amount. You almost have almost 4 times your amount. So doing this computation, going up and type in 30 times 24 for the N, leaving the I at 8, the PV at 0 because I don't have any money saved up already, the PMT 300, everything else is good. I go to the FV, hit my green alpha button, and hit enter, and I get the answer of $898,134, and I round it to 22 cents. 11 is almost a duplicate of 10. It's asking me how much money I'm going to have saved up in the future. The twist to it is I'm going to have some money already in my account, and the money that's already in your account for problem 11 is going to go in the PV, and problem 11 is a savings problem, so the sign of the PV and the PMT need to be the same. Either both positive or both negative. I generally would make them both negative. So 11 and 12 are basically the same problem. Then they want to answer the question, how much money I'm going to have at some point in the future. The difference between the last problem and this problem is they're $2 amounts as opposed to $1 amount. And when that's the case, I have to worry about my signs. In problem 11, as well as the next problem, I'm saving money. The dollar amounts need to have the same signs. If I had the dollar amounts with opposite signs, my balance would go down. It'd be like withdrawing money. So in this problem, to figure out how much money I'm going to have saved up in the future, it's going to be important when I enter this on my calculator to get both dollars amounts in. The PV is the amount of money that you already have in the account. The payment is the amount that I'm adding to that balance. And in this problem 11, because I'm saving, the amounts need to have the same signs. If I was withdrawing money, the numbers would have opposite signs. To finish this problem up, I see that I'm making deposits every 2 weeks. Every 2 weeks is not twice a month. That's the 26. Every 2 weeks is 26. Twice a month is 24 payments per year. In each one of these problems, the interest rate is assumed to be 5.5%. So I can do kind of problems 11A and 11B almost simultaneously because they're essentially the same problem. The difference between part 11A and 11B is the number of years that I'm considering. So for each one of these problems, I want to find out how much money I have in the future. For each one, the interest rate is 5.5%. The starting amount's $150,000. The payment is $400. I'm figuring out how much money I have in the future. I'm depositing every 2 weeks, which is 26. I'm leaving the calculator on end. The difference between part A and part B is just the length of time that I'm making those deposits for. For part A, it's 30 years, and if I just typed in 30, that would be like 30 deposits, which is just over a year. I have to multiply the number of years by the number of deposits per year to get the N. So the N for part A is going to be 30 times 26. For B is going to be 40 times 26. So I have both these strings ready for me to compute, so I'm going to do each. So for A, I'm going to do 30 times 26 for the N, 5.5 for the interest rate. I'm doing a negative 150,000 for the PV, negative 400 for the PMT, changing my PY and my CY to 26, and getting all those figures entered in. I'm going to cursor up to the FV, hit my green alpha button, and enter, and that's how I got the $1.5 million answer for 11A. To do 11B, to get this almost $3 million figure, the only thing I'm going to do is I'm going to change the only part that needs to be changed for part A. I'm going to need to change the N to 40 times 26. Go down to the FV, hit my green alpha button, and hit enter, and I get the answer of $2.864 million. So 11 is a slight twist on 10. It added just one layer of difficulty, which was the beginning balance when I'm making my deposits. I think 12 is a duplicate of 11, so that if you did 11, you should be able to do 12. A subtle difference is, in this problem, I'm only making one deposit per year, which is maybe unrealistic, but I just try to just throw this in here. So for each of these problems, I'm trying to figure out how much money I'm going to have in the future. For each one of these problems, I'm solving for the future value. Just like in problem 11, for my keystrokes on my calculator, the only difference is going to be what the N is. As I look at this problem, I'm saving money, and there's already money in the account. The PV and the PMT need to have the same amounts, the same signs. The PV is going to be the amount of money that you have saved up while you start making the bigger deposit. The PMT is going to be the deposit. And in both parts A and B of number 12, because I'm saving and I have $2 amounts, those dollar amounts need to have the same signs. In both parts A and B of number 12, the interest rate is 9%. And I'm only making one deposit per year, so for both A and B, the PY and the CY is 1. The nice thing about 12 is that the N is the number of years, because I'm only making one deposit per year. In 15 years, I'm going to make 15 deposits. In 40 years, I'm going to make 40 deposits. So I have my lines set up. Now I'm going to use these on my calculator. So the difference between 15 years and 40 years is quite a bit. It's $3.5 million. So if you start saving when you're 25, and you can put basically $800 a month away and get a 9% interest rate, which is reasonable over 40 years. You could have $4 million when you're 65. If you start when you're 50 and you put $900 or $800 a month away, or $10,000 a year is what this says, you only get $366,000. So the time is huge when you're savings. So the earlier you get started, the better. So to do problem 12A, for the N, I'm going to type 15. For the I, I'm going to type 9. For the PV, negative 20,000. For the PMT, negative 10,000. I'm changing the PY and the CY to 1. I'm going to hit my green alpha button and enter on the future value. And I forgot a 0 on the payment, or on the, I get the answer to part A of $366,458.11. That's all I'd have to enter on my answer blank on my test. Of course, you'd write down what you wrote on your calculator, just in case you made a keystroke error. I can give you partial credit if you show me what the kinds of things that you entered on your calculator. 12B, same sort of computation as 12A, other than I'm changing the N to 40. The only other thing, the answer is also going to change. The rest of the part, the I, the PV, the PMT, the PYCY are fixed. I cursor to the future value, type in alpha and enter, and I get this $4 million answer for part B. So 10, 11, and 12 were all savings problems. 11 and 12 were a little bit harder because you already had something in the account, whereas 10 didn't. 13, I think, is going to be the withdrawing problem, and 14 and 15 are going to be withdrawing problems as well. And withdrawing problems, if I have to enter $2 amounts, I have to have opposite signs. Fortunately, in 13, I only see $1 amount, so I don't have to worry so much about the sign of the dollar amount that I'm putting in. So for 13, 14, and 15, I believe I need to use the TVM solver to do each one of these computations. As I read through 13, the $400,000 is the amount somebody has saved up when they're ready to start pulling money out of their account. That amount needs to go into the PV. I'd probably make it negative, but really the sign doesn't matter because I only see $1 amount there to enter. And if I only have $1 amount, the sign's just not that important. As I continue reading through this problem, I see the person's going to get a 4% interest rate. They're going to withdraw monthly for 25 years, and they're going to run out of money. So for this particular problem, a person has $400,000 saved up. Say they're 65 and they want the money to last for 25 years till they're 90. They're going to make themselves a payment that's not going to go up over time of some amount, and assume that they get 4% interest for that 25 years. How much money can they pull out? Well, so the PY and CY is the 12 payments that you're making each year. The N is the number of withdrawals you're going to make, and that's going to be the 25 years times the 12 withdrawals per year. I'm assuming that after 25 years I'm out of money, and hopefully something like Social Security will carry you further if you need that extra money longer. And I'm going to solve for the payment. Or maybe you have nice kids at that point. So for this problem, I'm going to go to N. I'm going to type 25 times 12. That's 25 years times 12 payments per year. Usually when you're retired, you get very conservative, so your interest rates on your investments go down. Regardless of the sign I wrote on the PV, I'd get the right numerical answer. The 0 is the amount of money I'm going to have after 25 years. I made the PY and the CY 12 because I'm making 12 withdrawals per year, or monthly payments. And when I hit alpha and enter on the PMT, my calculator tells me that if I had $400,000 when I'm saved up on top of my Social Security, which might be $1,000 or $2,000 a month if that actually exists when you get there, you can pull out $2,100 per year. Of course, $2,100 per year right now or $2,100 per month right now might be a decent amount of money. 25 years from now, $2,100 per month would likely be, not that much money. So there are definitely many other factors to consider. Like, there's going to be a way to compute giving yourself a raise every year, but the TVM solver isn't sophisticated enough to figure out, how much you can start withdrawing and give yourself a 3% raise every year, so that you have the same purchasing power as things get more expensive. You need to be making more money. That the TVM solver can't do. That's good for a nice finance class like Finance 300 at ASU West might do that. That might not even be something they do, but it would be appropriate though. 14, same as basically a duplicate problem of 13. Person has $1 million. They want their monies to last for 30 years. They're going to make monthly withdrawals, and how much can they pull out each month? If you have $1 million, you should be able to pull out more every month than if you have $400,000. But I'm making my money last 30 years, and I'm getting a lower interest rate. So to figure out how much I can pay myself, The N is the number of payments I'm going to make myself. I want my money to last 30 years. I'm making monthly payments to myself. And for the N, I'm going to type 30 times 12. The I is going to be the interest rate in this problem, which is 3%. The PV, because there's only $1 amount, it really doesn't matter whether I make it a positive or a negative. Negative probably seems more appropriate to me, but it doesn't matter. I'm solving for what I can make, what I can pay myself. I'm going to run out of money in 30 years, and I'm making monthly payments. So I'm going to make the PY and the CY 12. I'm going to leave my calculator on end. So if I do these computations, go up to my N and type 30 times 12, type in 3 for the interest rate, and 1,000,000, whether I have the sign or not, is not going to matter on my answer, because when I write an answer down, I don't include the sign anyways. And the 0 for the future value, the PY and the CY at 12 are perfect. I go alpha and enter, and I get the $4,216.04 that a person could pay themselves, or a couple could pay themselves for 30 years if they had $1 million and they wanted to make it last for 30 years. I think the last problem on the review, no, there's two more. 15 and 16 both ask the question of how long my money's going to last, and they give me $2 amounts. It's a retirement problem. I'm pulling money out as opposed to depositing money. So if I read through this problem, I could see they're withdrawing money. When I'm withdrawing money, if I have to enter $2 amounts, those have to have opposite signs. So a person that's planning on retiring, probably a couple probably would be appropriate because I used the word there. A couple is, yeah, is seems fine. Planning on retiring. Their retirement savings is $500,000. They expect to earn 4%. They need to withdraw $3,500 per month. How long will their money last? I'm solving for N because to answer the question how long, that means you're solving for N. The interest rate that they're getting is 4%. The PV and the PMT are the deal breakers here where you can mess up. They're going to have no money in the future. They're making monthly withdrawals. If I put the same signs with the PV and the PMT, it's going to think I'm depositing money. So it doesn't matter which gets a positive and which gets a negative, but the PV and the PMT need to have opposite signs. Because the $3,500 is being paid to me and the $500,000 was money that I deposited, it's probably more correct to make the PV negative and the PMT positive, but it doesn't matter. My computation is going to give me the number of months. To convert months to years, I divide by 12. If you gave me either one of these answers, the 1,994 months or 16.19 years, I'd be content. So I go to my calculator. The interest rate needs to be 4%. The amount that they have saved up is $500,000. The $3,500 is the amount of the payment. I'm having 0 when I'm done paying myself. The PY and the CY are 12. I go up to N, hit my green alpha button, and I hit enter, and I get 194.31 months. Second and quit out of this. If I take the 194.31 and divide it by 12, I'll get the 16.19 years. So to pull out $3,500 per month, the couple would have to, their money would only last 16 years. If you start it when you're 65, it means you'd run out of this money when you're 81. If that's as long as you want to have the money, that would be fine. But you might have to reconsider if you want your money to stretch a little bit longer. So you can tweak it a little bit. You can change the dollars per month and figure out how long your money will last. But again, that's kind of beyond what I want to do. Last problem. Exact same setup as problem 16. Same thing here. Probably should be a couple is planning on retiring. Their retirement savings of $250,000. How much long is their money going to last? I'm going to solve for N. The interest rate I can quickly see is 2%. the PV and the PMT, because I'm withdrawing money, need to have opposite signs. I'm going to have 0 after I stop, after this amount of time. I'm making 12 payments per year. I'm leaving the calculator on end. So the $250,000 that the person has saved up when they start to pay themselves $4,000 per month needs to go in the PV. The PMT and the PV need to have opposite signs. The PMT is the $4,000 per month that the couple's paying themselves. When I do this computation, you only get 66 months. So if you had $250,000 saved up and you needed $4,000 per month of retirement income, and you didn't have any Social Security to help you out, or a pension or something, then your money's not going to last that long. $4,000 a month is almost $50,000 a year, so it's going to only last you 5 years, basically. So to do the computation here, apps, finance, I'm solving for N. I'm doing a very conservative 2% investment return, which unfortunately in today's interest rate world is actually a good interest rate. It's, my parents can't even get 2% on their retirement savings right now in the bank. You're lucky to get 1%. So I made everything how I wanted it to be. Made the PV and the PMT at opposite signs. I go up to the N and hit alpha and enter, and I get the 66 months. If I second and quit and type the 66.06 and divided it by 12, I get the 5.5 years, which is like 5.5 years, which is like 5 years, 6 months. So either of these would be appropriate for an answer. When you do an answer, I need to see units, whether it stands for months or years. If you're doing for time, for a dollar amount, I don't need to see the units because I understand dollars. But when you're solving for N, if you're giving me a month answer or a year answer, you need to say it's 66 months or 5.5 years, because 66 months is quite a bit different than 66 years. So not having the units attached would be not a good thing to do. So that's the entire review. Hopefully this is a good test. Hopefully this is at least moderately interesting to you. The answers on my handout show all the keystrokes that I typed in as well, just in case you didn't get something written down as you're going through the video. All the keystrokes I wrote are right there.